All right, so I'm going to go ahead and put up the graphs that I made, not by hand. This is generally what these should come out to look like. Histograms, both of them look pretty much like that. Box plots, one of them is smaller than the other, but they have the same basic shape to them. I'm not getting right up close, so I don't see the minimum and maximum values necessarily. On the box plot, what do you notice about the median there? It's in the middle. Is it close to the center, or is it clearly closer to the left or the right side? Looks pretty close. Like, if I squint at it, I can see that it's a little closer to the left-hand side, but for the most part, it's in what I would call the middle of the box. Like, it's not clearly one side or the other. And then we have our stem plot and our split stem plot, and then our summary statistics that I went ahead and ran so that we could have a decent discussion about this. So I'm curious, in describing this distribution, what are the 4 things that we have to hit on again? Shape, outliers, center, spread, or variability. Yes, spread or variability. And then we always have to make sure to work context in here. Anytime you're asked to describe a distribution, you have to get context in. Putting units on your measure of center and on your measure of spread is a good way to get context in there, along with repeating the question stem or whatever title it was that you put on your graph, which I'm loving that I'm seeing titles and keys on almost every single graph. Make sure to put titles, and for the stem plots, you want to put a key so that they know that it's not a decimal point, it's a whole number value. In this case. Hold on, sorry, I just completely lost my train of thought. Nope, it's gone. Whatever it was is gone. Describing our shape. Which one of these displays do you like the best for describing the shape? Yeah, like standing across the room, the histogram, I can see the shape of it pretty clearly. I can also see it pretty clearly in the stem plot, over here and over there. You can see that. If I were to take this and turn it the other way, you'll notice that the numbers kind of line up with the bars there. How would you describe the overall shape of this? Do you think it's roughly or approximately symmetric? Do you think it's skewed to the left? Do you think it's skewed to the right? You said skewed right? So my only issue with saying skewed right, I'm going to come over to this one, not because it's a favorite or not a favorite. So skewed to the right, I would probably want to see a couple other ones out here because it needs to have a tail. Now, I agree this guy out here looks weird and it draws my attention. Did anybody check this to see if it was an outlier? Was it? No. Was it close to being an outlier? Yeah. It's really close to being an outlier, but it's not an outlier. When I look at this, if I imagine the mean, the average, as being about here-ish, what did we say the mean was from those summary statistics? 34-ish, right? 33.8. So that means right here is the balance point. The mean is the balance point. And so on either side of it, does it have a roughly similar appearance? There's more over here than there is over here, right? But I notice it kind of goes down to just one value over here. On this side, we've got this big bar here, and then it comes down. We're missing this. We do have a noticeable gap there that I might mention. I would probably go with roughly symmetric on this one. Just because, like, these two are about the same distance away from that middle. If we've got a skewed distribution, you will see a tail off to one side. So either the left side or the right side would be farther away from the middle on those maximums and minimums. Yeah, I would probably describe this as approximately or roughly symmetric.
So if it's not an outlier, we don't even consider the tail being there.
If there's not an outlier?
Like if it's not, yeah, because you just said that it wasn't skewed to the right because that part is not an outlier.
So let me grab my chalk real quick. I've got about 4 minutes left if you need it or if you're finished. Are you all done? Okay, you can put it on my desk. Take the pass back to class. All right, so for a right skewed distribution, I think a distribution kind of like this. If I were to kind of trace over the top of a histogram and I see this general shape, do you see how like the big bump is here?
Yeah.
So the mean is going to be somewhere here-ish, not too far away from that big bump of data. But the right side is very clearly longer than the left-hand side. This doesn't necessarily have an outlier. It might, I don't have the data set. It might have an outlier, but it might not. So it's possible to have data filling in all these pieces here without this weird guy, and it could be skewed, even though there's not like some outlying piece. Does that make sense?
So then if it could be skewed, like why wouldn't we say that it is?
So when I'm looking at the difference between like this representation, this graph here, and this graph here, I'm guessing that the mean is here. Ballparking it. The mean for this one is right here. I'm looking at this distance as compared to this side. Whereas over here, when I go from the mean out to the edge, and then I do it on the other side, I'm hitting about the same away from it. Does that help?
Yeah.
Okay. That's what I'm looking for there. It's possible to have an approximately symmetric distribution that does have an outlier. So you can have it looking approximately symmetric, and then there still might be this one weird data value, like my 65 shoes from the other day.
So also, I remember yesterday you saying something about like if it's skewed we use median and if it's symmetrical we use the mean.
Use the mean, yeah. So that rolls me right into the next thing I was going to ask about. We need to describe our center. If we describe this as roughly symmetric or approximately symmetric, then I would use which measure of center? The mean. So I would say the data is centered, or the center of the data is approximately at whatever, or the mean of the data. If you say the mean of the data, that's understood to mean you're talking about the center. So you don't have to say the word center in there. So mean is 33.89, and then we need units with that. 33.89 what? Home runs. Is it okay that it's a decimal, even though you can't have 0.89 of a home run? Yes. When you're doing the mean, when you're doing averages, that doesn't necessarily mean that that's a value that could be taken on by our variable. Yes?
So when you're talking about the center, you don't need to say like the center?
You don't have to say the word the center. You can. There's nothing wrong with that. But you could also just report the mean is 33.89, and then we could go on to talk about the spread. So it's possible that you can do a description in like 1 or 2 sentences. Depending on the data, sometimes you'll want a sentence for each of the things, so you'll end up with 4 sentences total. You can kind of group them together as long as you hit those 4 pieces. It doesn't matter how many sentences you use to do that. What measure of variability, what measure of spread should we use? We said this is approximately symmetric. So what measure of variability or what measure of spread? Standard deviation. I would use standard deviation. If you use the mean to describe the center, then you would use the standard deviation to describe the spread. Now, that being said, if you don't have access to the mean or the median, let's pretend we didn't run these summary statistics and I just gave you the histogram. I didn't even give you the raw data. If all I give you to look at is the histogram, you're going to have to ballpark where the center is. And in that case, then I would say the center is about at. Because it can't really tell you where the median is precisely. I don't have that raw data. Does that make sense? So we use what we can. If I have access to all the summary statistics, then I would go with mean and standard deviation if it's approximately symmetric. Were there any outliers? No. Data would have had to be smaller than what to be a low outlier? Smaller than -5 to be considered a low outlier. Is that even possible in this situation? No. Or it would have to be larger than what? Larger than 75 to be an outlier on the upper end. Yes. All right. So I wrote this in 2 sentences. Distribution of home runs for Barry Bonds. There's my context. Fairly symmetric with a mean of 33.89 home runs and a standard deviation of 15.41 home runs. There are no outliers. So you can do it in 2 quick short sentences if you want to. Yes? Does it have to be in the order of socks? That's a good question. It does not. As long as you hit all 4 pieces, you can arrange those sentences or their place in the sentence wherever you want. As long as you hit those 4 big ideas, order does not matter. And then I've got a couple advantages, disadvantages for each of the different type of data displays, but I'm curious, as you made your data display, what's something that you liked where you're like, I'm glad I got this one and not whatever? Or what was a disadvantage? What did you not like about the actual construction of it? You're like, this was tedious, this was hard, this was, yes? Box plot wasn't detailed enough. It is really hard to see the shape because with that box plot, well, we get the approximately symmetric. Does it show the gap that the histogram shows? Stem plot also shows that gap. With box plot, I can't see gaps like that. I also can't see how high any peaks are. Yes? Yeah. What'd you say? Oh, and it's okay to like it. Like I said, I just wrote down like some real quick, like this is something I like about it, this is something I don't like about it. This is not an exhaustive list. I'm going to repeat this and then I'll be right back there. So one of the things that you said you didn't like, oh, you liked that? You don't have to figure out the scale. If you're doing a histogram, you have to figure out how big your bins are. Even if you're doing a box plot, you got to figure out what you're counting by on the x-axis. If you're doing a stem plot, you don't have to think about that. You got to write down all the numbers that are in the tens or hundreds place, and you're good. All right, yes?
I think I like dot plots are less because they're very easy to read, like from district's point of view, a nice general idea.
Yeah, dot plots, you have all your raw data. Pretty easy to read. I do think they're easier, like if you were trying to read information off of a dot plot versus a histogram, you're going to be able to be more precise about things. I can use a dot plot or a stem plot if I wanted to find the median, if I wanted to find Q1 and Q3, if I wanted to find the IQR. If I wanted to find the mean, I could, since I have all of those raw data values there. Yes, that's an awesome one. Anything else that you liked or didn't like? No? Okay. Let's look at number 5. So now we have another distribution. It was given to us as a dot plot. Can you compare distributions if they're not being represented the same way? Like if one's a dot plot and one's a histogram, can you still compare them?
If they had the same data, yeah, right?
Well, if you're comparing the same variable. Like in this case, we've got a variable for how many home runs.
Yeah.
and we've got it about 2 different people. So I wouldn't compare like home runs for Barry Bonds and how many sit-ups Ms. Bolt can do. Like, I would not compare those 2 things. Answer, not very many. But yeah, you can compare different types of data displays. We should still be able to compare the overall shape. We should be able to compare the centers. We should be able to compare the spread. And we should be able to talk about outliers from either type or from any of these different types of data displays. All right, so looking at Mark McGwire, we described Barry Bonds as approximately symmetric. What do you think about Mark McGwire's? Skewed or approximately symmetric or? Yeah, I think this one looks roughly symmetric too. I think it looks roughly symmetric. You're going to find that a lot of the data that we look at looks roughly symmetric. And we usually give like a wide berth of wiggle room if you're going to say roughly symmetric to something. How do the centers compare? They're exactly alike. We have a 33.89 for Barry Bonds. Mark McGwire is 35.6. So Barry's a little bit lower, right? When we're comparing distributions, I want to make sure that we're using every comparison word that we can. So the only way I would describe the centers as being the same is if they came out to be exactly the same. Or if I'm looking at, say, a box plot, and I can't tell any decimal values here necessarily, but they're right lined up one on top of the other. Since we have our summary statistics, I can say that one is a little bit more than the other. Yes?
I was talking about the medians, because can't we still talk about the medians as a
Oh, good point. So they have the exact same median. So you could talk about the medians.
Because the median is still lower for, well, is it? Where's the
See, median is 33.5. Median is 33.5, so they have the exact same medians. If you describe the data as roughly symmetric, then you should be comparing the means. If you describe the data as skewed, then you should compare the medians. It might be interesting to point out in a comparison that while Mark McGwire's mean is a little bit lower than Barry Bonds, their medians are exactly the same. So their centers are very close to each other, but they're not identical.
If we ever added that to the test, would we get it wrong for adding?
Nope.
No?
Nope.
As long as we have the right one still there, like the median.
Yeah. The big thing when the AP readers are grading the tests, and so I grade your chapter tests in a similar fashion so that you're used to it. As long as you don't say anything incorrect, if you just include extra information that I wasn't looking for, as long as it's correct information, you're fine. It's not going to take away points at all. What would take away points is if you give like 2 what they call parallel answers. They're both kind of answering the question, but one is right and one is wrong. I have to look at the wrong one.
Dang, that's crazy.
I know. So if you're on the fence, don't give 2 separate answers. If you give 2 separate answers that are different from each other, you're going to get it wrong. Like, make a decision, go with your gut. If you're like on the fence about one or the other, make a decision and report that.
I got another question.
Yes.
So you know how we have like the little SOX abbreviation?
Mm-hmm.
So you said it doesn't have to be in order, but it all does have to be there. What if we got one of them wrong with the rest of them right?
It's not going to hit you for everything. On the AP exam,
So you'll give us points for the one we got right?
yeah, I'll give you points for what you get right. Yes. Yes. On the AP exam, if I'm not mistaken, when you go to describe a distribution, they're looking for those 4 pieces plus context. If you remember context, you can usually get away with forgetting one of these, and you'll still get an E on that section. If you forget your context, it doesn't matter if you have all of these. It goes from an E to a P. So it would drop down a level. How do the spreads compare? How does the variability compare? Is one higher than the other? Which one's higher? Mark McGwire is higher. He's got a standard deviation of 18.69. Barry's was 15.41. So yeah, he's got a slightly higher standard deviation. And then, do either of these have outliers? Not really. So here's my comparison. Notice it's a little bit wordier than when I just described Barry Bonds' distribution. I said the distribution of home runs for both Barry Bonds and Mark McGwire are fairly symmetric. The mean for Mark McGwire is 35.60 home runs, which is slightly higher. If you don't have a less than, greater than, higher, lower word, and you're doing a comparison, you're not going to get points for it. You have to use those higher, lower, greater than, less than words, something that shows me that you made a numerical comparison between these two distributions, which is slightly higher than Bond's mean of 33.89 home runs. McGwire's standard deviation of 18.69 is also higher than Bond's standard deviation of 15.41 home runs. Neither distribution has any outliers. So still hit every piece of socks, but in there you want to be comparing the two things. Comparing the two things. Comparing the two things. Make sure you're using greater than, less than.
And what about the review? Will the review be turned into for points or not?
No, I do not collect the reviews for points.
Oh, actually, you
I
can
will take questions over them. So Monday we're going to practice with some free response questions. Probably going to have you guys work in groups on those also, because I really love the conversations that I'm hearing around the room. Those are super useful. So we'll look at a couple of free response questions, and then on Tuesday, my plan is that I will take questions off the review. I do post that answer key on Canvas, so you will have access to every single answer there too. All right? I'm also going to try to work in some multiple choice practice.